Alright, 1.6 number 17, you're supposed to figure the period, the domain, the range, draw a graph of the function. Okay, so this is about as tough of a problem as you'll see. Probably tougher than most problems you had back in pre-calc and algebra 2 if you did this in algebra 2. So it's probably not fair for them to just toss this in. So I'll try to talk it through. So they've got anytime you have a number in front here, a coefficient, you have to pull that out. So I'm going to pull a 3 out, but then you'd be left with pi over 3 right here, minus 2. Okay, so anytime you're graphing cosecant, I always like to graph the reciprocal function, which is sine. So I'm going to graph the same thing, except it's going to be the sine. And we're going to use the sine graph to graph the cosecant one. So I like to do 4 things. I'm sure this is different than what you've seen Mr. Frisbee do or whatever, but I look for 4 things in the graph here. I look for period, amplitude, I call it a locator point, and then up by. Okay, so period for sine, cosecant, secant, the period's always 2 pi over b, and your b is right there. So the period is 2 pi over 3. The amplitude is the number out front, that's 3. The locator point is the opposite of that, comma that, so negative pi over 3, comma negative 2. And up by is the period divided by 4. So my period is 2 pi over 3 divided by 4, or times 1/4 would be 2 pi over 12, which is pi over 6. Alright, so there's our information. Let's see, I'm starting at negative pi over 3, I'm going up by pi over 6. So I'll go by pi over 6's. Negative pi over 3 plus pi over 6 is negative pi over 6, and 0. Pi over 6, pi over 3. So that's 2 pi over 6, plus another pi over 6 is 3 pi over 6, which is pi over 2. 3 pi over 6 plus a pi over 6 is 4 pi over 6, which is 2 pi over 3. 4 pi over 6 plus a pi over 6 is 5 pi over 6. And we can go backwards too. Alright, maybe that's enough. Okay, so my locator, now I'm graphing sine here, is negative pi over 3, negative 2. Right there. So remember sine, since it's a positive leading coefficient, the general positive sign looks like, there's my locator, like that. A negative sign starts down and ends up at the midline right there. So this one's a positive, so it's going to start at a locator and go up. The amplitude is 3, so the next time it'll be up 3, 1, 2, 3, going up by pi over 6. 1, 2, 3. Oops. Alright, so there's my graph of the sine one here in red. So now if I was going to graph the cosecant one, first thing you want to do is anytime your sine is at the midline, that's where we're going to have an asymptote on the cosecant. So we're going to draw these guys. And then the cosecant comes down and hits it. Okay, so the graph is our cosecant graph of all that stuff. So now we graphed it. What else do we have to do? Period. Oh, we did that. The period is 2 pi over 3. Domain, range, and graph. Okay, so the domain and range of our cosecant. So what I do is I look for the first vertical asymptote. So it's going to be everywhere except for the asymptotes. So for the domain of the cosecant, you'd say all reals except for where there's an asymptote. So there's an asymptote here, here, and here. I find the first vertical asymptote at or beyond the y-axis. Well, this one's right on the y-axis. Okay, so we can just say starting at 0 plus, and then how often do they occur? Pi over 3, another pi over 3, and so on. So pi over 3n or pi over 3k. And you don't need the 0 there, but if it had started at like pi over 4 and then it's going up by pi over 3, then you'd put your first vertical asymptote right there. Okay, so it's all reals except for pi over 3n, where n is considered an integer in math. Like if n was 1, there's no, it's not part of the domain right here. If n is 0, it's not part of the domain. If n is -1, it's not part of the domain because -1 times pi over 3 is right here. So that covers all the vertical asymptotes. The range, we know we go all the way up to this point, which is -5. So y has to be, I'll go interval notation, -infinity to -5, and then union, meaning combining the two intervals. Then it starts at 1 and goes up, so from 1 to infinity. There's your range. Okay, hopefully that makes sense. That was only, one problem. You may want another example or two, but hopefully that helped.